This is 6.1 part 2. I can perform transformations of functions, so we're going to be working on more transformations. I wrote this off screen, so that's why you can read it a little more clearly. Horrible penmanship here, I apologize for that. So in the warm-up it says, describe what each of the following transformations would do to g of x. So this is g of x, and in this case they multiplied it by 3. In this case we've got g of x, and inside the parentheses with the x they subtracted 3, and then on this one we've got g of x, and then we added 3 here. So you'll notice that every single one of these involves a 3, but they're all going to transform this in different ways. So hopefully you were paying attention to the part 1 of this. Hopefully this is going to be pretty easy. So here's what happens here. Because this number is bigger than a 1 and we're multiplying outside the parentheses after the function made the shape, this is going to be a vertical stretch. So I'm going to write down vertical stretch, and I'm going to write down 3 times taller. Whoops, 3 times taller. 3 times taller. That's what that one's going to do. Notice that this one is inside. Now, when we change the x before it makes the shape, it does something in the horizontal direction. So it does, we're going to have a horizontal change here, and it does the opposite of what we'd think. So you would think that if we're going to move this horizontally, that it's going to move it to the left 3 units. It's not. This is going to be a horizontal shift. Horizontal shift. So this is actually going to move this to the right 3 units. So I'm going to write right 3 units. Okay, last one here. We've got g of x, and then we add 3. Again, because we've made the shape and then we're adding something afterward, that's going to be a vertical change. So this is a vertical shift, and this is going to move it up 3 units. Remember, vertical changes do exactly what we'd think. So this is going to move it up 3 units. Now, again, the big idea here. The big idea is that functions make shapes when we graph them. And what we're doing now is we're taking transformations, and now we need to know what transformations do. Transformations change those shapes. All right, so functions make shapes, and then transformations of those functions change the way the shape actually looks. Now, there are 3 transformations in the warm-up question. Those are ones that are most common. Those are what we did in the last section. There are 3 others that we need to learn, and we're going to do the easy ones first, but we want to make sure everybody remembers this because we already mentioned this. Okay, if we change x before the function makes the shape, so let's write the word before here. Before the function makes the shape, then it changes it in the x direction. Now that's a horizontal direction, and I've got an asterisk by this because remember, it does the opposite of what you'd think, and this is going to be a big player today, so make sure you catch that. If we change the function after it makes the shape, then it changes it in the y direction, and that's the vertical direction, and it does exactly what we'd think. We don't have to think quite as hard on vertical changes as we do on horizontal changes. Now, before we do each one of these problems, take a look at what changed. Notice where the parentheses are. Figure out whether there's a change inside the parentheses with the x, or is it outside? Did it change before it made the shape, or did it change after it made the shape? That's going to be the determining factor of whether or not it's a horizontal or vertical change. So I've got a slightly different piecewise function here, so I'm going to slide down and we're going to take a look at these first couple of examples right here. It says perform the transformations and sketch the graph. So like we did yesterday, I'm going to go ahead and take a look at this, and now wherever there's an x, we're going to put a -4. So I'm going to put a -4 right here. So this is f of -4. -4 is -1. So this is going to be negative f of -4. So I'm going to put a -1 right here. So we're taking this function value right here and we're multiplying it by a negative. So what we end up with is negative times negative is positive. So we end up with -4, 1. Next one, we're going to put a -2 right here. So this is negative f of -2. So let's figure out what f of -2 is. It's a 1. So this is going to be negative times 1, so that's going to be -1. So we're going to graph this point right here. Let's see, 0. So we put an f of 0 in here. So this is going to be negative. Let's figure out what f of 0 is. That is a 1. So this is going to be -1. So that's what we're going to graph. And then we plug in a 2. So this is a 2. And you'll notice what's happening here is I'm basically just going down this list because these x values are all the same. I'm just taking each one of these and I'm multiplying it by a negative. So this used to be a -1, now it's a +1. This used to be a 1, now it's a -1. This used to be a 1, now it's a -1. Well, if you multiply a 0 by a negative, it doesn't change the sign at all, so that's still 0. Let's see if this would work right here. We're supposed to multiply this by a negative, so let's say we think that's -2. This is going to be f of 4, so negative f of 4. That's a 2. We multiply that by a negative. Yep, worked out just fine. Now let's see what this did. You'll notice that this is outside the parentheses, and you'll see on this table we changed each one of the each one of the y values. The x's were already picked for us. The y's changed. So let's see what we've got here. We've got negative 4, 1. So negative 4, 1. We're right here. Negative 2, negative 1. So negative 2, negative 1. 0, negative 1. And then we've got 2, 0, so over 2, and then don't go up or down, and then 4, 2. So we're going to go down to, 4, negative 2. So 4, negative 2 would be this. 4, negative 2 is right there. So let's connect those, and let's see what we've got here. Okay, now, well, gosh, it looks kind of like that, but let's see if we can graph that original one and see if we can tell what's going on here. This would be negative 4, negative 1. Negative 2, 1, 0, 1, and then this one was right here, and then we were up there. So this is what the original one looked like. Okay. Now, hopefully you can see what's going on here, and I'm going to come in here and I'm going to draw a green line on this. This is a line of symmetry. This is a mirror line. So if you were to tilt your head completely to the side 90 degrees, you can see that this point that was up here flipped down here. These 2 points that were up here flipped down here, and this point that was down here flipped up there. And the point that was right on that line of symmetry, right on the line of reflection, if you will, then it stayed right where it was. So this flipped over the x-axis. It did what we call a vertical flip. Now let's take a look at this next one. So this is f of negative x. Okay, so here's what we've got to do on this one. We've got to plug in a negative in front of that x. So we've got a negative, whatever x was, that's negative 4. So this is going to be f of 4. So we actually have to go up here and we have to figure out, well, it changed the x. It changed this from negative 4, it changed it to positive 4 because we're doing the opposite of that. And then we need to find out what f of 4 is. F of 4 is 2. So I'm going to put a 2 right here. So we would graph 4, 2. Let's do the next one. This would be negative 2. So that would be f of 2. Whoops, make that look like an f of 2. So this is f of 2. And f of 2 is 0. So we would graph that one. And again, this gets a little bit complicated with the negatives, all those negatives in there. So this is negative, whatever we're plugging in for x. So let's see, that would be just a 0. So f of 0 is 1. So we would graph this one. And then we're going to plug in a negative. We plug in a 2. This is a little bit easier to see what's going on here once they turn positive. So we've got f of negative 2, and f of negative 2 is a 1. So we would graph this. And then we're going to do a negative, whatever the x is. We're going to put a negative in front of it. So this is going to be, let's see, f of negative 4. F of negative 4 is negative 1. So these are the ones we're going to graph. Now, let's see what we've got here. So this is negative 4, 2. So we're going to go back 4 and we're going to go up 2. So we're going to go to right there. Negative 2, 0. So right here. 0, 1. So that's going to be right here. And then 2, 1, that's going to be right here. And then 4, negative 1, that's going to be right there. Okay, so this is going to look like this, and this, and this, and this. Now, you can kind of tell what happened here going from the original graph to this one right here. These horizontal changes are kind of ugly. So let's take a look here. Let's graph that original one. It started right here, went up to there, over to here, and then it went down to here, and then it went up to right here. So this is the original one. Now this might be a little bit more difficult to see. I'm going to draw a line on here. I'm going to draw a line right there because here's what happened. What we did is we took this blue point right over here and we flipped it over there. Okay, so we flipped it right across the y-axis. We flipped it horizontally over here. We took this point right here that was at 2, 0, and we made it negative 2, 0. We took this point right here that was on the x-axis, or on the y-axis, and it stayed right there. And then this one we flipped over this direction, and this one we flipped over this direction. So what happened here is a vertical flip. We flipped it across the x-axis. What happened here is a horizontal flip. We flipped the right for the left. We flipped it across the y-axis. So we're going to slide down here. And again, these are kind of hard to figure out and a little bit ugly. This vertical one was not too bad. But if we've got a negative outside that f of x, this flips it across the x-axis. So it flipped it like this right here. Okay, we sometimes call this a vertical flip. Changed it in the vertical direction, so we call that a vertical flip. The shortcut here is because it changed it in the vertical direction. We multiplied all of those function values by a negative. It changes the sign of all of the y coordinates. Notice it's a vertical change, so we're going to change the sign of the y coordinates. And then if we've got a negative in front of an x inside the parentheses before it makes the shape, that's going to flip it across the y-axis. It's going to reflect it across the y-axis, and we sometimes call this a horizontal flip. Okay, seems a little bit weird that when you're flipping across the y-axis, you're doing it horizontally, but we're trading the right side for the left side and the left side for the right side. And the shortcut to that is it changes the sign of the x-coordinate. So again, notice a horizontal flip here, we're changing the x-coordinates. Vertical flip here, we're changing the y-coordinates. Now, I do have a quick question for you. This is kind of a tough thought question, but I want you to think about this for just a second. Why does f of negative x not do the opposite of what we'd think, just like all the other horizontal changes do? So normally when we change something inside the parentheses, change the x before the function makes the shape, it does the opposite of what we'd think. And this one does exactly what you'd think. You multiply by a negative, well, it flips, changes every x for a negative x. It flips that back and forth. Okay, so why is that? Well, the reason for that is we are making the x's the opposite of what they used to be. So we are making x's the opposite, get that to erase there, the opposite of what they used to be. And here's the bottom line. Opposite is opposite. I mean, once we've done the opposite, once we've made it the opposite sign, there's really not much else that we can do. So I want to slide down here and I want to take a look at this question at the bottom here. The last type of transformation looks like this. So we've got a 2 times the x inside the set of parentheses before the function makes the shape, or we've maybe got something like a fraction, like a 1/2 inside the parentheses with the x before it makes the shape. So I want you to think about whether or not those would make horizontal or vertical changes. And also think about what we've done so far. So we've got a vertical flip, taking the top and flipping it to the bottom and bottom to top. We've got a horizontal flip, just flipping the right to the left and so forth. And this right here, think about what's going on with this one. If we're multiplying the x by something inside the parentheses before it makes the shape, this is going to be a horizontal change. So let's flip the page over and let's take a look at this other side. All right, so we're on the other side. We're on example 5. It says perform each transformation and sketch the new function. And it says, note on B, the table is not filled out, so choose the x's wisely. So this is function B. We've got a couple of points filled out. That looks a little bit weird. We're going to need to fill those out completely. And again, it's the same parent graph, same parent function, so we've got the function values right there for us to refer to. So here's what we're going to do on this one. Again, favors done for us. They've chosen some x's. So here's what we'll do. We're going to do 2 times x. So this is 2 times -2. So that's going to be f of -4. So f of -4 is a -1. So we're going to graph these points right here, that x and that y. So we're going to do the same thing again. We're going to times whatever x is by 2. So this is going to be f of -2. And f of -2 is 1. So we're going to graph these guys right here. Let's see, 0. So this is going to be 2 times 0. So that's going to be f of 0 here. So f of 0 is 1. So we're going to graph these. And then we're going to do, let's see, this would be 2 times 1. So that's going to be f of 2. So that's going to be, let's see, f of 2 is 0. And then we've got this one right here. So this is going to be 2 times 2. So that's f of 4. And let's see, that's a 2. Okay, so we've got that. And let's try this one right here. This would be 2 times 3. That's going to be f of 6. There is no f of 6. There's no function value out here. So we're going to write NA again. We've seen that before. And that sometimes is typical with horizontal changes. So let's go ahead and take a look here. We're going to graph -2, -1. So back 2 and down 1. And we're going to graph -1, 1. So back 1 and up 1. 0, 1. So we don't go right or left. We just go up 1. 1, 0. So we're right there. And then 2, 2. So 2, 2 would be right here. So the graph looks like this. Kind of a tiny little thing. And I'm going to graph the original one on here. So the original one looks like this. Remember, it started off at 4, -1, -4, -1. Okay, and then went to here, whoops, here, and here, and to here, and then up here. Okay, so 4, 2, and then 2, 0. So this is what it looked like. This was the original one. Okay, looked like that, and like this. So the original shape was kind of drawn out and stretched out like this. And what we've done here is we've kind of shrunk this down. Okay, it's kind of like about maybe half the size of what it used to be. So this used to be over here at 4, now it's only at 2. This used to be at -4, now it's only at 2. This value right here used to be at -2, now it's only at -1. And this one used to be at 2, and now it's only at +1. Okay, so let's go ahead and take a look at this next one, see if we can figure that one out. We've got a 1/2 here, and I'm going to change just slightly the way I'm doing this work. So I'm going to do 1/2 of whatever this is. So this is going to be a -4. So I want to find f of -4, and that's a -1. Okay, so we're going to graph this. I'm going to do the work up here. So this is 1/2 of -4. 1/2 of -4 is -2. So that's going to be f of -2. That's a 1. So we're going to graph this. Now, in order to make these work out, you'll notice that this value right here worked out to be the -4. This value right here worked out to be the -2. I need this next one to work out to be a 0 so that I can find that one right there. So what would I multiply 1/2 by to get a 0? Well, I'd multiply a 0 by 0. Okay, so this is going to be a 0. So we're going to do 1/2 of 0. So that's 0. And f of 0 is 1. Okay, so we're going to graph 0, 1. And then the next one, again, notice what we've got here. Whatever this number was inside the parentheses, it doubled to get this one outside here. Okay, so what we're going to do, we need to get a 2, so we're going to need to use a 4, so that when we multiply that by a 1/2, we get f of 2, because 1/2 times 4 is 2. And then this one, we need to make a 4, so we're going to do 8. So we can do 1/2 of 8, so that's going to be f of 4 right here. So this will allow us to pick up these last two function values. So that one's a 0, and f of 4, that one's going to be a 2. So these are what we're going to graph right here. Now, I picked these values right here. We kind of found those. It takes a little while to get used to how this works and why we would pick those. But remember, what we're doing is we're taking this x value right here and we're multiplying it by a 1/2. So if we need it to work out to be a -4, we'd have to have it be twice as big to start out with. So that's why it's a -8. And then the same reasoning right here. If we need a 2 for the x, we need this one to be twice as big as that so that when we cut it in half, it works out to be the 2. So nonetheless, let's go ahead and graph this and see what this transformation does. So we get -8, -1, so we're right here. -4, 1, so we're right here. 0, 1, right there. 4, 0, right there, and then 8, 2, so right here. So let's go ahead and connect these pieces because we know we've got these little lines that connect those. And let's see what happens here. Now, that is definitely a different shape than it was to begin with. I'm going to come back here and graph that original one. Again, we started here to here to here to here and then here. So there's a dotted version of the original one. And take a look at what's happened here. So this was at 4, 2. It's all the way out here at 8, 2. This was at -4, -1. It's all the way out here at -8, -1. Now you'll notice that the y values didn't change on either one of these. What changed were the x values. Okay, so we're going to slide down here and let's talk about what happened. So the factor of 2 shrunk those little x's, those little x values right here. So like it used to be 4 and now it's 1/2. It shrunk them by 1/2. And the factor of 1/2 right here stretched the original ones by 2. So this used to be 4. So this x value used to be 2. And once it got stretched, it's now a value of 4. This one used to be 4 and now it's an 8. This one used to be a -4 and now it's a -8. So what I'd like you to notice here is notice that reciprocal relationship between the factor and how much it stretched or shrunk. So when it was a 2, we actually shrunk this horizontally by a factor of 1/2. It made everything, all the x values, half what they used to be. And over here, when we were multiplying it by a half, it actually stretched them by a factor of 2. So it actually took all these x values and multiplied them by 2. Even this one right here, this point right here was negative 2, 1. It stretched over here, and it's now negative 4, 1. There's that negative 4, 1 right there. Okay, so there's that reciprocal relationship, kind of like an opposite. So I'm going to write down opposite right here, and I'm going to put that in parentheses. A reciprocal isn't really an opposite, but it does kind of do the opposite of what you'd think. You would think that this would horizontally stretch it out. It doesn't. It shrinks it, and you'd think that would horizontally stretch it. Shrink it. It doesn't. It actually stretches it. So let's come down here. This is the last one, and this is probably the most complicated one. So if we've got a horizontal stretch or shrink, so again, notice we can tell it's horizontal because it's inside with the x, and it's being multiplied by that number. So if it was outside in front there, it would be a vertical stretch or shrink. It's inside here with the x, so it's going to be a horizontal stretch or shrink. Because it's inside, again, that tells us that it changed the x before it made the shape. So this transformation changes the x before it makes the shape, so it does the opposite of what you'd think. When you multiply x by b, it makes the x's go faster or slower than it normally would. So again, horizontal changes are kind of hard to understand why they do what they do, but here's the deal. When we multiply it by a number bigger than 1, so I'm going to write down bigger than 1 right here, and I'm going to put that in quotations right here. What it does is it speeds it up and it shrinks the interval that it takes to make the shape. So let me slide up here for just a second. This is what happened on this one. It made that shape, kind of this piecewise weird shape like this, it made that shape in half the time because of that 2. It sped it up, it made that shape in half the time. Now, on this one where we multiply it by 1/2, what happens is it slows the function down. Okay, so it slows the function down, so it stretches out the interval needed to make the shape. So normally it would make the shape from negative 4 to 4 in about 8 units. It actually takes it from negative 8 all the way to 16 to make that shape because it's going half as fast as it used to be. Now, that's kind of a complex explanation, but these are really good skills to have. Luckily, we do some of these harder ones, the horizontal stretches and shrinks, we do them much less often than the other ones. Okay, so hopefully you've got the basic ones in hand, and then those horizontal stretches or shrinks, we can kind of tackle those as we come to them. Now, depending on the graph, some of these changes are harder to see and tell apart from others. Now, once you know all of these and you've practiced these, you're going to be able to transform any shape, any graph that you come across. It's a really helpful skill, so please work on this hard. So we've got a couple of examples left on the notes, and then we'll take a look at number 1, number 9, and number 15 from the assignment. So on number 6, it says, describe the transformation. Now, notice that this is inside the parentheses with the x. We've multiplied it by 5. So this is going to be a horizontal something. Let's see, normally if you multiply something by 5, normally you'd think that that gets bigger, it stretches it out. It doesn't. In this case, it does the opposite. It's a horizontal shrink, okay? So it makes it in less time. So makes shape in 1/5 of the time. Makes it in 1/5 of the time. All right, so it speeds up by a factor of 5, makes it in 1/5 of the time. Now on this one right here, we've got g of x, and then we've multiplied it by a negative outside. So that's going to be a vertical change of some sort. So remember, if we multiply that by a negative, we're taking all the y values and we're multiplying by a negative. So that's going to be a vertical flip because we're changing the y values, changing the top for the bottom, okay? And we'll just write down that this is a reflection, or we'll say it reflects across the x-axis, okay? We're taking all these y values that are up here, and we're flipping them down here, all of these y values that are down here, and we're flipping them up there. Okay, and then it says write the transformation of the function h of x given the description. So h of x is vertically stretched by a factor of 5. All right, vertically stretched, we know it's going to be outside the parentheses. It's going to be after the function makes the shape. So that's going to be h of x. And if we want to stretch it, you'd do exactly what you'd think. We're going to multiply it by a factor of 5. So that's going to be 5 times h of x. If you want to put a dot there, that would be okay. And then the last one on the note says h of x is horizontally flipped across the y-axis. So again, horizontally flipped. So what's going to happen is we've got this shape over here. We're going to flip it over here. So the right and left switch sides. So horizontal, let's see, we're going to flip this. It's got to be inside the set of parentheses. And if we want to flip something horizontally, we just multiply it by a negative. So that would be the answer on that one. Now, again, once we practice these, we're going to do several all at once. We'll get really good at them. We might run across something that looks really ugly like this. Okay, don't worry about the pluses and minuses. We'd either have a plus or a minus. They look really complicated, but once you get used to them, they're not too bad. We'll be doing some things that look like this. We might be doing 2 or 3 transformations at the same time. And one last thing that I want to point out that we're going to use, it's often helpful to make the shape. In other words, make that new shape that stretches and shrinks first, and then move those key points where they need to be. And I'll show you what that looks like. So let's do the self-assessment, and then we'll look at problems number 1, 9, and 15 on the assignment. All right, here's worksheet 6.1b. So let's go ahead and take a look. We've got this parent graph right here, along with a table of values, and it says complete the tables, sketch the resulting graphs, and describe the transformation. And it says hint, if you want to describe it first and then graph it or fill out the table, that's totally okay. So here's what we're going to do. I'm going to take this and I'm going to fill out the table first on this one. We're going to take all the f of x's, those are y's, we're going to multiply them by a negative. So all the x's are going to stay the same. So this is going to be -4, -1, 1, 3, and 4. All of those stay the same. And what we're going to do here is we're going to change the y values. So this is going to be a -3. Multiplying a 0 by a negative doesn't change it. We get a -2, another -2, and then we get a 1. Remember, when we multiply by a negative, it just changes all those signs. So here are the x and y values that we're going to graph. So this is -4, 3. So -4, -3. So we're down here. Then -1, 0. So -1, 0 would be right there. 1, -2. So over 1 and down 2. Over 3 and down 2, and then 4, 1. 4, 1 would be right here. So we get this shape just like this. Okay, now that's what it looks like, and maybe you can tell what's happening here. Well, what we've done here is we've taken this and we've vertically flipped it. Everything that was up above is now down below, and everything that was down below, which was just this point right here, is now up above. So this is going to be a vertical flip, vertical reflection if you wanted to get technical about that. And I'm going to come back here. I'm going to draw what that original one looked like. It looked like this, and then we came up to here. It was flat for just a second, and then it went like this. And you can kind of see that, that horizontal line of reflection, that line of symmetry right here. It's the x-axis. We flip everything up here, down here, and everything down here, up here, and so forth. Okay? Now, we were going to look at that one, and we were also going to look at number 9 and number 15. So we're on page 2. Here's number 9. We just need to describe the transformation on number 9. So we've got this 1/3 with the x inside the parentheses. That's before. So that's going to be a horizontal change of some sort. So I'm going to write horizontal. And then we've got to figure out what's going on here. Remember, if you multiply by a number, that's going to be either a stretch or shrink. And you would think that multiplying by a third is going to make it smaller. It doesn't make it smaller. What happens is it slows it down, so it takes the reciprocal of that 3 times as long. So this is a horizontal stretch. So what that means is it's going to change all of the x values. So I'm just going to write down it's going to multiply all x values by 3. Okay, so it's going to multiply all the x values by 3. That's because it slowed it down, so it takes 3 times as long to make that same shape. All right, so we've got our answer right there. And then let's take a look at number 15. It says x is horizontally shrunk by a factor of 10.